This actually came a bit out of the blue for me, and that makes it even more fun that someone sort of dug up my research online. So I'm really happy to be here and to be able to have a presentation about behavioral environmental economics, I guess you could say. So my name is Claes, and I'm a postdoc at the University of Gothenburg. And I guess it's going to be sort of two-part, this presentation. I'm going to talk a little bit about the role of behavioral economics in general when it comes to environmental economics and also environmental policy in general. But the main thing is going to be sort of an example of this from my own research, a study we're doing now, and I'm actually currently writing up the paper for this. So that's in the title here, that's the example on household waste. And for my part, I'm totally happy to answer questions as we go along. I think the presentation, I've tried it out and it should be somewhere around 40 minutes. But anyway, obviously we have time for questions, so yeah. Right. So just a bit of a primer. I guess many of you know this already, but sort of what is behavioral economics? So I like to call myself a behavioral environmental economist. So first, just to give you an overview of what that is. And of course, as with anything, academics disagree exactly on how to define this, but I think one useful definition was in this paper by Mulainat and Thaler in 2000, where they say that behavioral economics is basically about three classes of deviations from the neoclassical model of human behavior, the so-called Homo economicus model, economic man model. And those three types of deviations are, first, bounded rationality, which means the economic man knows exactly what is good for him, and that is the assumption that's being relaxed here. So in real life, we don't always know what's best for us, and we may have various kinds of cognitive biases. There's a whole list of them. I've just put in two particular examples. One could be a default effect, that we're sort of, we tend to go with whatever is the default, no matter what that is. And that's something that Homo economicus would not do, because he would judge all of the alternatives on offer in a sort of disinterested, rational way and pick the best one, no matter which one is sort of first in line and easiest to choose, even though it's not really a cost to go to opt out rather than opt in to a default. So that's one example. Another one is loss aversion, going back to Kahneman and Tversky in the 70s, which is the idea that losses are perceived as more bad than the corresponding gain is perceived as good. So we try harder to avoid losses than to seek gains, which means that a given change is perceived differently depending on whether it is framed as a loss or as a gain. In neoclassical theory, we would think of gains and losses as more or less the same thing. A loss is just a negative gain, essentially. Whereas in real life, that's not really how people work. So that's the first class. It's various kinds of cognitive biases, which means that we have trouble seeing what the best option is. The second one is bounded willpower, which means that people, even if people know what the best thing is, they have difficulty choosing it. So in real life, we have various kinds of self-control problems. We procrastinate, we eat too much unhealthy food, we exercise too little, and so on, even though we know and think that that's bad for us, we still do it. And that's also something that the rational agent in a neoclassical model would not do. And finally, third, the third class of deviations is bounded self-interest. So the economic man only cares about his own payoffs, whereas in real life, we care about what happens to other people as well. And there are various ways in which we might care about what happens to others, and not all of them are benign. But I've listed down some of the sort of main candidates here. First, altruism, that we simply want what's good for other people. Another thing is inequality aversion, which is that we like outcomes that are sort of equitable. That's not exactly the same thing as fairness necessarily, that you care about outcomes that are fair, because you might think that in certain situations, at least, it might be that you think that an unequal outcome is fair, because maybe, for example, one person has contributed more or something like that, worked harder, and then you think that that person should have more of the pie, so to speak, bigger piece of the pie than the person who didn't work much. And that could be fair as well. And finally, reciprocity, which is, well, the benign version of that is that someone else is good to me, then I want to be good to that person. But of course, there's another side of that coin, which is that if someone behaves badly towards me, then I want to punish that person and make sure that something bad happens to that person. So various kinds of bounded self-interest, also known as social preferences in the research literature. So this is essentially what behavioral economics is all about, looking at assuming something like this instead of assuming away all of these kinds of things. So it's really about making more realistic assumptions about human behavior and seeing where that takes you. And I would say, so I started my PhD 10 years ago, and over that period of time, I think I've seen that this type of approach has become increasingly mainstream in research. However, it has not really been, there has not really been an equivalent breakthrough when it comes to teaching. It's definitely when it comes to teaching at the introductory level. That's all still very much about neoclassical theory, but I think in research, it's become much more accepted to sort of keep an open mind, to be pragmatic and say, sometimes in some situations, incentives really are the main thing that people react to. But maybe in other situations, they're not. Maybe in other situations, it's much more about like you go for whatever is the default or something like that. So what's the point then of behavioral economics? Well, one thing is that when you take on these assumptions instead of the neoclassical assumptions, that may, of course, lead to other conclusions about which policies work and how well they work. So, for example, there's this literature, there's kind of mixed evidence, but there's a literature on something called motivation crowding, which is the idea that in some situations, putting an incentive might actually undermine the behavior you're trying to promote. So there's this famous study where they started paying parents for picking up their kids in kindergarten, and fewer parents actually did that because now it was sort of by paying for being there on time, the interpretation is that that sort of made it okay not to be there on time. You just pay the fine and that's it. So obviously, making a behavioral assumption leads to a totally different conclusion about whether you should have an incentive for the behavior you want to promote. So that's one thing. Another thing is that behavioral economics itself may suggest policy. And those tend to be policies that somehow leverage these three classes of deviations we had up here. So the main example is nudges, which was sort of a term that was coined about 10 years ago. And the idea of a nudge is to alter what they call the choice architecture. So it's essentially, when you choose among alternatives, you have these alternatives lined up, but maybe they're organized in some way that makes you slightly more, or even much more likely to choose one of these alternatives over the other, no matter what their sort of rational ranking would be. So a typical example is that one of them is a default. So in order to choose something else, you have to say, I don't want that one. And that's something that people seem to be less likely to do. So in that sense, if you just change what the default is, you really have an impact on behavior, which has, that operates through a completely different channel than this sort of rational choice that we tend to think about usually in economics. So moving on to environmental economics, I'd say the main policy prescription to come out of the behavioral literature here is so-called norm-based feedback, the point of which is to reduce the use of some resource. So the main example for this are the so-called home energy reports. There have been a number of studies on this, mostly in the US. These are letters that you receive as a household, which compare your mainly electricity or energy use, that's mainly what it's been used for, to the averages among some set of peers. It tends to be neighbors. So a set of 100 neighbors. Here's how you're doing compared to your neighbors. And the point of that, again, is to reduce the electricity use among the households receiving those letters. I think it's fair to say that these letters tend to reduce use. The only thing, though, is that it's not clear by how much. So there's an increasing discussion of what the effect size from these kinds of interventions really is. So in these electricity studies in the US, reductions tend to be about 1 to 2%, something like that, among receiving households. But when a couple of Germans tried to do this, to replicate this in Germany, they found a smaller reduction, only 0.7%. And they argued that this may well be because there's more scope to reduce electricity in the US than in Germany, where baseline use rates are lower to begin with. And they also concluded that sending out these letters as a way of reducing carbon emissions would be cost effective in the US, but not in Germany. So this reduction in the effect was sort of enough to make it an inefficient instrument. Of course, if we don't care much about cost efficiency, we might want to do it anyway, but still. And there's also maybe reason to think, and this is actually sort of the starting point for our paper, which I'll get into very soon. There's reason to think that these effect sizes may be domain specific, that is specific to whatever it is the feedback is about. So a few studies have also done this for water use. And there, the reductions tend to be larger, about 5% rather than 1 to 2%. So getting into our study, so this is a project together with Magnus Söderberg, who is at the University of Southern Denmark, but lives in Gothenburg. So he comes around the office sometime, or he used to, back when I used to come in the office. So what we do is that we apply this kind of feedback to household waste instead, which is something that no one has really done before on a large scale. And we think that we might have even bigger effects there. Right? There's reason to think that should be the case. And my reasoning behind this is related to sort of the costs of doing something as a household. So we might think of those costs as related to two types of actions. The first one is that you could reduce gross use. And by that, I mean that you could engage in fewer activities that consume the resource to begin with. So you watch less TV or something when it comes to electricity, or you buy fewer products that generate waste in the waste domain. And typically, you only really have variable costs here. So it's like there's some kind of effort per amount that you save. But I think the effort associated with reducing resource use in this way is pretty high. So I think these variable costs are pretty high, I'd say. The second way in which you could reduce use is by reducing net use. And that's some kind of efficiency enhancing measure. So when it comes to electricity, you could buy a different TV or something like that, one that uses less electricity. Or with waste, you could recycle your waste. So you still generate waste, but it's handled in a less, in a sort of more environmentally friendly way. And depending on the domain, that kind of action comes with both fixed and variable costs potentially. When it comes to electricity, it's mostly fixed costs. You have to buy the new capital stock, so to speak. You have to buy a new TV or a new dishwasher or whatever. But once you do that, the variable costs are quite low. You almost don't have to do anything after that. Whereas with recycling, there's almost no fixed cost involved at all. You might want to buy some new containers to have in your kitchen for the sorted waste, but those only cost what, a few tens of euros or something like that. And then of course you have higher variable costs because you have to recycle your waste and you have to maybe go and drop that off somewhere. But we think that overall, considering the fact that with electricity you have very high fixed costs and rapidly rising variable costs, whereas with waste you have low fixed costs and not that rapidly rising variable costs, though maybe they start out a bit higher. Because of that, we think that the scope for reducing the unsorted waste that you throw is much lower than achieving deep cuts in electricity use. So that's sort of our prior here. So this domain may represent some kind of best case scenario for when it comes to effect sizes for this kind of norm feedback intervention. Of course, we're going to see in a minute whether that's the case or not. So what we actually did was that we ran two separate but simultaneous large-scale randomized controlled trials in two municipalities in Western Sweden, Varberg and Partille. I'll show them on a map on the next slide, or maybe the one after that. In these municipalities, the waste system is kind of dual. So first of all, the municipality collects two types of waste: food waste and residual waste. So food waste is like the organic waste fraction. It's not necessarily the same as wasted food. because it includes stuff like banana peels and bones and so on. And residual waste is the unsorted fraction. It's whatever is left after you've done your recycling. Second, the other types of waste, specifically packaging and newspaper waste, are dropped off at specific recycling stations. That is, if you live in a single family home. If you live in an apartment, you typically just go down to the basement. And the distance to the recycling station, well, if you live in some kind of urban area, it's usually no more than a few hundred meters at the most. So our feedback concerns the residual waste here, and that's expressed also in kilograms per person to make it more comparable across households. And the reason we focus on residual waste is that we think that, you know, no matter how you manage to reduce that, it's probably a good thing, except maybe if you go dump it in the woods or something like that. And related to that, both of these areas also use unit-based pricing of waste. So it's a marginal cost. You pay per kilogram of waste. It's a marginal cost pricing for waste. And that's in Sweden, that's pretty rare. But it's good for us because that means that the municipality weigh all of the bins that they collect, so food and residual waste, as they're being collected. And that goes into a huge spreadsheet file, which we've been able to tap into. Whoops. There we go. And it's using that file that we've been able to construct its feedback. So the feedback is household specific and it's accurate. And that's all because of this unit pricing system, because they weigh the bins. Now, of course, that means that sort of our study also relates to like whether you should have those systems or not, because if you do have them, then it's possible to add something like our intervention on top. And there's quite a lot of discussion about that, mainly because there's a worry that when you price waste by the kilogram or by the bag or whatever, then there's a danger of dumping. I should say, though, that in our data, we don't really find much evidence of that. It doesn't seem like dumping is very common in these municipalities. And it also doesn't really seem like it increases, at least not by much, from our intervention. It's maybe like there are 5 incidents a year, and maybe we have 6 incidents a year or something like that after this. Yeah, so we did this in 2019. We only included the single family homes because we want to be able to say, you know, we have to pinpoint each household. We can't do that in apartment blocks because we only know the total from each building then. But this still leaves us with 15,000 households in Varberg and 5,000 in Partille. And we split the set of households into 3 treatment arms in each municipality, one of which was always a control group where no letters were received. But then we did slightly different things in the two municipalities. So in Varberg, we looked at 2 variants of the letters. So we have something we call the static norm and something we call a dynamic norm. Both of these, of course, I'll explain the differences in a while. These were all received every 4 weeks for 8 months. So these groups received 9 letters, I think. In Partille, everyone received a static norm, but we changed instead the frequency. So we had one group receiving only, I think, 3 letters. So once every 12 weeks instead. And we wanted to see essentially, do we still have the same effect? Because then we can make this whole thing cheaper by sending out the letters less frequently. So here is where these areas are on the map. Varberg has a central town here, and then quite a bit of rural area around it. Whereas Partille is a proper suburb of Gothenburg, the second largest city in the country. Here's the static norm. This is a very faithful, I'd say, recreation of these home energy reports that people have used for electricity. The main thing is this bar chart up here, which, as you can see, has 3 bars: your household, then your neighbors, that set of 100 neighbors or so, and then the efficient neighbors, which is the top 20%, so to speak, among these neighbors. So it's the ones with the least unsorted waste. And then depending on where you are, where your household is compared to these other 2 bars, you get an evaluation down here. So if you're better even than the efficient average, you get 2 smileys and it says excellent. If you end up in between the efficient and the overall average, as this household does, then you get 1 smiley and it says good. And if you're worse than the overall average, you don't get a smiley and it says room for improvements. It's pretty harsh in the end, but we at least we didn't have a sort of frowning smiley. And then down here, you have a sort of comparison over time for the last year. And that's just these 3 bars again, but sort of tracking them over time. So the black solid line here, that's your household. And then you have up here the overall average and the efficient average. That's the static norm. The reason why we call it the static norm is that most of it, or at least this part here, is sort of a snapshot image of what the state of the world is right now. And we've been reading some psychology papers that argue that if you want to change people's behavior, you shouldn't actually focus on that kind of this is what's happening right now. Instead, or this is what behavior looks like right now. What you should do is that you should focus on the changes that are occurring. It's not like 20% of people are eating less meat. It's more like 20% of people are starting to eat less meat, because that is, they argue, that's more effective at triggering some kind of reevaluation of what you're doing. So it's like, oh, people are changing their behavior, and maybe something is changing out there. And maybe I should be looking at whether I should eat less meat also, sort of like that. So we wanted to try that because no one has ever really done that in a large scale sample like this. It's only been a few hundred participants in those psychology studies. So this is what we came up with. And it's not, we call this a dynamic norm, but we still have the bar chart down here. So what we actually do is that we replace this year-long retrospective with this box up here where it says during the latest period your waste weight was 0.3 kilograms per person lower than during the preceding 4 weeks. So what's been happening since the last letter was received? Over the same period, 45% of your neighbors have managed to reduce their waste by more than your household. So again, it's focusing on the changes that have been occurring while still sort of contrasting what you have been doing compared to what other people have been doing. So we wanted to see if that makes more of a difference than this static norm did. So here is essentially the raw data from this experiment. And the nice thing about the setup that we have, the experimental design, is that I can basically just present you with the raw data, and that still tells you everything you need to know. So we have down here, we have periods. Those are 2-week periods because the collection cycle for waste is 2 weeks long. So that's how we chose to structure the data. And this is a period of about 2 years. The first letters are sent out here by the vertical line. Then on the y-axis, you have average residual waste, so the outcome variable we're interested in. And you have those averages for each of the 3 treatment arms. So the control group, and then the static norm, and the dynamic norm. I should say this is only for Varberg. So that's why we have static and dynamic and not monthly and quarterly feedback. So what happens here? Well, first of all, you can see that these averages follow each other very closely indeed, all the way up to the vertical line here. The reason they do is because we randomized which group you're supposed to be in. And the neat thing about randomization, of course, is that it tends to eliminate all average differences across the groups. So they really become comparable. You can use one as a counterfactual for the other. That's the point of randomization. And then clearly, once we send out the letters, something happens here. We get a divergence here, a gap. And the gap is such that the control group is on top, which means that you actually have a reduction in the other groups. Again, because of randomization, we believe we're able to interpret the control group as a counterfactual for what would have happened to the letter groups if they had not received letters. And in fact, because these averages are so close together before treatment happens, before the letters are received, we can essentially just take this gap, this vertical gap here, and interpret that as the effect size. Of course, we do run regressions and stuff like that as well, but in principle, we would expect the effect size to be on the same order of magnitude as this gap. I'll get back to exactly what the size of that gap is, but we can see already here that the average here is something like 3 kilos per person, and the gap is something like 0.25 kilo per person. So this is an effect size of about 8%, something like that, which of course is much bigger than people have found for electricity at least. Here's for Partille, and this is slightly less clear cut because here randomization did not quite work as intended. And the reason for that is simply, we believe, that Partille is a smaller municipality. So we had, there was an increased risk that for purely by chance that you wouldn't be able to eliminate all the average differences across the groups. But still, we think that something is going on here because look at the control group line here. That's below the others all the way until treatment. And then it switches around and comes out on top. So if we think in terms of differences in differences, then it seems pretty clear that we have an effect here as well, going in the same direction as in Varberg, the other municipality, which is essentially a drop for these 2 letter groups compared to the control group, in relation to the control group. And actually, when you run the regressions, what you estimate then is an effect size, which is more or less the same as in Varberg. Again, sort of 8% or so. Let's see, was there a question? No. There we go. So when we run the regressions, those confirm an effect of about 8%. We also tried a nonlinear model, something called the log normal hurdle model, which does 2 things. First, it accounts for the fact that we have quite a lot of zero weights in our data, which means that in that particular 2-week period for that particular household, there was no waste collected. that happens in about 10 to 20% of all observations, I think. The other thing is that we have a right-tailed distribution of weights collected from the households. So we have a few households with very large weights. And it seems like there's sort of the distribution is kind of exponential. And this type of model also accounts for that. And when we do that, we have we estimate even larger effects that are more like on the order of 12%. So it seems like overall, depending on exactly which model you use, you get a reduction of about 10%, which again is much larger than we've found for electricity or water use. We tend not to find any significant differences across the treatment pairs. So the static and the dynamic norm were performed about equally well, which we can also see here because they tend to be quite close together here. There's some indication that the quarterly letters did not work quite as well. So I'm going to go back and see if I can figure something out regarding the trade-off there. For like, if you send them out less frequently, of course, they're going to be cheaper, but also maybe have a smaller effect. There was a question?
Yes, if I may, the control group and both the static and the dynamic group, they all show like similar spikes and drops.
Yes.
Do you have any way of explaining how that can be the case? So could it maybe be that there was like a holiday and then there's more food waste or something?
Absolutely, yes. So these are all for the unsorted fraction, and basically almost everyone has one unsorted bin and one food bin. So if they're been sorted correctly, which incidentally we know that they haven't been, but still, these graphs should pertain to sort of the other stuff, not to food waste. In any case, this is Christmas, and this is Easter, and this is summer, midsummer, and that's actually quite interesting because Varberg, lying at the coast, as you saw, is a holiday resort in the summer. Partille is not, and actually there you have, let's see, here's Easter, I think, and here's Christmas, and here's summer. So there you have a drop instead, which we interpret that as like people leaving Partille on the sort of net and going to Varberg, of course.
People celebrating Midsummer Varberg.
Yeah, something like that. People going on a holiday. So it's like you have a net increase in waste in Varberg because that's a net recipient of people at that time, whereas you have a net reduction in waste in Partille because that's a sort of a net giver of people in the middle of summer. And you have essentially the same patterns again the year after, which is over here. So I think this might be Easter and this is summer or something like that. And here again, here's the second summer. And of course, if you were to do just a sort of before and after comparison, these kinds of patterns would be a big problem, right? Because you could go from, I don't know, you could go from here to here and say, whoa, these letters increase waste a lot. But because we're randomizing, we're able to control for all of that. So we don't have to worry about these kinds of fluctuations over the course of a year at all. And that's again, the nice thing about randomization. Yeah, so I was talking about differences across treatment. So we do suspect that maybe the dynamic norm was a bit less popular, purely from sort of anecdotal feedback we've gotten from angry people calling the waste office and so on. So we think that maybe, you know, that box we put on the letters there that maybe that put households a little bit more on the spot, because it's quite a stark comparison between how they have been doing and what other people have been doing, really emphasizing the people who are better than you, right? So maybe that could be, and in any case, given that we had the same magnitude of the effect, I think I would recommend to stick with the standard formulation, the static norm, in the future. We've also done quite a bit of work trying to look at the mechanisms. What is it that people actually do to reduce their waste? Now that's tricky, unfortunately, because we don't really have much good data on the other types of waste that the municipality does not collect, packaging and newspapers mainly. We are able to look at food waste, and it does seem that that is not a big part of the picture here. There is a slight increase in food waste, which is consistent with people getting better at recycling food waste, but it's quite small compared to the corresponding reduction then in residual waste. We did have a survey, though, that we sent to people. Unfortunately, the response rate was low. But in those responses, it seems like the most common thing that people said that they'd done was to get better at recycling packaging waste. So we still think that that is probably the main change that people implemented. So just a few extensions before summing up. This is just a first look at the long run results. So this line here, that's the end of the last picture. So this is going on through all of 2020 here. And I think that this, also relating to the question you had before, I think this is summer now. So there's something going on in Varberg in the middle of the COVID pandemic. People don't go there anymore, so there's no spike anymore. But the main point is, of course, that the control group average stays on top of the other ones all throughout this year, and we didn't send any letters after this point here. So it's very persistent. Even a year afterwards, more than half of the original effect stays in place. And that's also, of course, good news for this kind of intervention. Final thing is that we also looked at who is reducing waste. And the main thing here, so there's one picture here for each of the 4 treatments we had in the different municipalities. And the main thing to note is that these lines are all downward sloping, broadly speaking, which means that the ones reducing the most are the ones to the right here, which are the ones that generate a lot of waste to begin with. So the high users are the ones that reduce the most. That's a pattern that people have seen for electricity and water use as well. So it's not surprising as such, but of course it's nice to be able to replicate that when we're doing this kind of thing in a new domain. So finally, based on this study, it seems like this kind of feedback is quite promising for reducing household waste. So we think that it may, as I said in the beginning, represent a kind of best case scenario for this kind of intervention. Still, it's only a 10% reduction. So it's worth asking what the place for behavioral interventions in environmental policy really is, if the best we can get is a 10% reduction, right? I find myself in a kind of awkward position here because I'm coming down as a kind of a relative, I guess, skeptic of these kinds of interventions, even though I do research on them. Generally speaking, I would say I'm quite pragmatic about these kinds of things. You have to look at them case by case, not only, different interventions, different types of interventions case by case, but also the thing that you're applying to them case by case. And I would also tend to think of them as complements rather than substitutes of whatever else it is that you could be doing. Still, if you think about climate change, at least, the challenge there, of course, is not to reduce by 10%, it's to get down to net zero. And that requires some kind of, well, obviously, we're not gonna, replace the entire energy system with this kind of intervention. It seems pretty obvious to me that it's gonna take more. This is not to say that that behavioral interventions never work. For example, people have done studies on changing the default option for pension savings. That has a huge effect. So it's not like you never get more than 10% of whatever it is you want with this kind of intervention. It really depends on what you're trying to do and how you're trying to do it. Here, though, it seems like most of the things that you can do on a large scale tend not to have very exciting effects. Also, it seems to me that you could only do this kind of thing with resources that are somehow being procured by the public sector. So suppose you were to get this kind of letter from your local gas station or something like that. We've seen that you have been using more gasoline than your neighbors have. I would imagine that there would be a major pushback from consumers from that kind of thing. So if I were to venture to produce some kind of bottom line here, I would say that these things, when it comes to environmental policy, they can still be useful, but there's certainly no panacea, and maybe it's best to apply them on top of whatever it is you're already doing. So they could be a complement to standard policies like carbon pricing or renewable standards, subsidies or investments, whatever. So yeah, this was the last slide. So that's it for me.